Welcome, everyone. This is our Apex Labs training on good laboratory practice, and we're going to be focusing on really the most critical part of what we do, actually performing the study.
So here's what we're going to cover. We'll look at the Apex Lab standard, the study plan itself, what to do when things change, amendments versus deviations, how to handle our raw data, and finally, how to uphold the integrity of the entire study. It's all about making sure our work is solid.
All right, let's jump right in. We're going to start with the absolute core principle, the thing that guides literally every single action we take here in the lab.
You see this right here? The study should be conducted in accordance with the study plan. It sounds so simple, doesn't it? But this is the bedrock of GLP. It means every single thing we do, every observation we make, every piece of data we collect has to tie directly back to that plan. It's our North Star, our source of truth.
Okay, to make all of this feel a bit more real and less like a textbook, we're going to follow a case study. Let's imagine our new study director, Dr. Anya Sharma. We'll see exactly how she applies these principles to a really important study she's running called Project Catalyst.
And that leads us right into the study plan itself. Now, I'm not exaggerating when I say this is probably the single most important document you will ever handle in a study. Seriously, think of it as the blueprint for the entire project.
So what exactly is a study plan, according to the official GLP definition? Well, it's the document that lays out the objectives and the entire experimental design. It's not just a suggestion, it defines everything. And you'll notice it also says includes any amendments. We'll get to what that means in a bit. The bottom line is, if it's not in the plan, we don't do it. Now, this next part is absolutely crucial. The study plan has to be approved by the study director before any work begins. And I mean any work. You can't take a single sample, you can't record a single observation until that plan is formally signed and dated. That signature is basically the starting gun for the entire study.
Okay, so here's where we translate all that regulatory language into something practical. Look at how this works for Project Catalyst. A good study plan isn't vague at all. It's super specific. You've got to have the title, who the sponsor is, the dates, the exact test methods you're using, even down to the species and strain of your test system, and a list of all the records you're going to keep. It's all spelled out.
All right, let's be realistic. In any study, especially a long or complex one, things are going to change. It's pretty much inevitable. So the key to staying compliant isn't to pretend change won't happen. It's all about how you manage it and, more importantly, how you document it.
And this brings us to a really key distinction, amendments versus deviations. Think of it this way. An amendment is a planned change. It's intentional. Dr. Sharma decides she needs to add a new data collection point to Project Catalyst. That's an amendment. She has to document it and approve it before it happens. A deviation, on the other hand, is an unplanned departure. It's reactive. An instrument breaks down unexpectedly. That's a deviation, and we have to document it after it happens.
And the GLP rules are super clear about this. You see the quote here. Deviations have to be described, explained, and acknowledged. This is all about transparency. We don't sweep mistakes or unexpected problems under the rug, ever. Instead, we face them head on. We document them, we explain what happened, and the study director signs off on it. It's about owning what happens, good or bad.
So, here at Apex Labs, we have a very clear four-step process for this. First, you identify that something's gone off plan. Second, you document it immediately. What happened, when, who saw it. Third, the study director, in our case, Dr. Sharma, has to assess the impact. How does this affect the study's integrity? And finally, fourth, we take whatever corrective action is needed and document that too. It's a simple, traceable workflow that protects the study.
Okay, let's move on to what is, you could say, the very heart of our study's integrity, the raw data. Everything, and I mean everything, rests on this. It's the evidence, the foundation for all our conclusions. So what do we mean by raw data? Well, it's pretty much everything. It's the original record. It could be a number you write down in a notebook, a printout from a machine, or an electronic file saved by an instrument. It's the first original recording of an observation. And because of that, it's sacred. It has to be captured correctly, right away, and it has to be readable. Let's look at a classic example of what not to do. See this? This is the wrong way to correct data. It's a huge no-no. Why? Well, for starters, you can't even read the original number anymore because it's been totally scribbled out. And there's no explanation for the change. No initials, no date. An auditor looking at this would have zero clue who changed it, why they changed it, or when. The data is basically worthless now. Okay, now this is how you do it. This is the right way. Notice the difference? There's just a single line through the original number, so you can still read what it was. The new value is written clearly right next to it. And, this is the most important part, there's a reason for the change, transcription error, followed by the initials of the person who made it, AS for Dr. Sharma, and the date. This is transparent. This is defensible.
And look, these same principles apply 100% to our digital systems too. There are 3 big rules here. 1. The system has to have a full audit trail. It has to track every single change: who, what, when, and why. 2. Your login is your signature. Don't ever share it. It's legally tied to you. And 3. Just like on paper, if you change any data, you absolutely must provide a reason why.
All right, let's wrap this up by pulling everything together. Upholding the integrity of a study, it isn't about doing one thing right. It's about consistently applying all of these principles every single day, throughout the entire process.
So what are the big takeaways here? First, plan everything meticulously. Your study plan is your Bible. Follow it. Second, manage change formally. Planned changes are amendments, unplanned events are deviations. Document them both. Third, record your data accurately. It's got to be direct, prompt, legible, and you have to know who recorded it. And finally, uphold integrity in everything. Every action you take has to be traceable and transparent. That's how we generate data that is valid, reliable, and that everyone can trust.
And that really leaves us with this one final thought. Your data, it's your legacy. It tells a story. So the question you have to ask yourself every day when you come into the lab is, how will you protect its integrity? Because at the end of the day, the quality of our work has huge real-world consequences. It's about protecting health and the environment. It really matters.